The Sun is a star located at the center of the solar system and serves as the primary source of light and energy for the system. Below is a description of the Sun and how it operates. 1. Basic characteristics. Structure. The Sun is predominantly composed of hydrogen, about 74% by mass, and helium, about 24%. Heavier elements make up a small portion. Temperature and pressure. The average temperature of the Sun is around 15 million degrees Celsius, 27 million degrees Fahrenheit, at the outermost layer called the corona. Pressure and temperature increase from the core outward to the surface. 2. Nuclear fusion process. Fusion. In the Sun's core, hydrogen undergoes fusion, transforming into helium through the fusion process. In the core, due to extremely high pressure and temperature, hydrogen particles are compressed, forming helium and releasing a significant amount of energy according to the equation E equals mc²2, Einstein's law. Solar energy. Energy from the fusion process converts into light and heat, generating gravitational force and pressure from this hot gas mixture, creating a balance in the solar furnace. 3. Heat and light transmission. Solar light. Energy from the fusion process radiates outward, forming light and heat. This is the primary source of light for the Sun. Heat transmission. Light and heat are transmitted out of the Sun and reach the Earth, providing energy for life and contributing to climate phenomena on the planet. The Sun sustains life and the activities of the solar system by supplying energy and light to the planets and other objects within the solar system. Planets orbit the Sun due to the force of gravity, an attractive force acting between Earth and other objects in the solar system. This is a phenomenon specifically described by Newton's law of gravity. Gravity. Gravity is the force of attraction between two objects with mass. In other words, every object with mass exerts a gravitational force on every other mass. Newton's law of gravity. Newton's law of gravity describes the gravitational force between two objects. According to this law, each object exerts a gravitational force on the other object, with the force magnitude proportional to the product of their masses and inversely proportional to the square of the distance between them. Circular motion and Kepler. When an object moves in a circular trajectory around another object, such as a planet orbiting the Sun, the gravitational force and the momentum of the motion create a circular or elliptical orbit. Kepler's 3 laws describe the motion of planets around the Sun. These laws explain the orbiting, structure, and time ratios of planetary motion. Planets orbit the Sun due to the balance between gravitational force and the momentum of motion, creating orbits that maintain the stability of the solar system. Planets do not move in a straight line, instead, they orbit the Sun in specific trajectories. The Moon orbits the Earth due to the gravitational interaction between these two bodies. This is an example of a smaller object, the Moon, orbiting around a larger one, the Earth, due to gravitational forces. Here is a detailed explanation. Gravity. Each object with mass creates a gravitational force. For the Moon, the gravitational force is primarily generated by the Earth. Gravity and momentum. The Moon was initially formed from materials in Earth's atmosphere, hypothesized by the giant impact hypothesis. Due to the mass of the Moon and the distance between the Earth and the Moon, the gravitational force between them generates a momentum. The momentum creates a rotational motion around the Earth, forming the Moon's orbit. Circular or elliptical orbit. The Moon moves along an elliptical orbit around the Earth. This is the result of a balance between gravitational force and momentum. Tidal interaction. Tidal interaction between the Earth and the Moon also plays a role in slowing down the Moon's rotation. It increases the gravitational force between them, leading to a synchronous rotation where the same side of the Moon always faces the Earth. In summary, the Moon orbits the Earth primarily due to the gravitational interaction, combined with factors such as tidal interaction and momentum, creating a stable dynamic system between these two bodies. A nebula is a vast, cloud-like structure in space, often taking the form of large, colorful clouds. They are typically observed through the light emitted by nearby stars or other light sources. Nebulae are formed through the process of star formation and can later become sites for the formation of planetary systems and other star systems. Here's how nebulae are created. Formation of nebulae. Nebulae often form from elements and chemical compounds expelled from stars when they reach the end of their life cycle without having enough energy to maintain the balance between gravitational forces and thermal pressure in the core. Radiation from nearby stars can stimulate the molecules and dust particles in the surrounding space, creating the bright and colorful appearance of nebulae. Types of nebulae. Emission nebulae. Emission nebulae are primarily created by young, hot, and bright stars. They often contain elements such as hydrogen, helium, oxygen, and other light elements. Dark nebulae. Dark nebulae are often seen when stars age and evolve into red giants or supernovae. They contain more dust and larger particles, giving a sense of darkness. Star formation and stellar systems. When a new star forms from a cloud of gas and dust, part of the surrounding material is blown away, creating nebulae around the newly formed star. Throughout the evolutionary process of a star system, nebulae can also house planets, stars, and other stellar systems. In summary, nebulae are fascinating space structures created from materials expelled by stars and often serve as the birthplaces and developmental grounds for the universe. Star clusters in the universe exhibit a tremendous diversity in both characteristics and structures. Star clusters can vary in terms of size, mass, temperature, stellar class, as well as in the energy processes and internal compositions. Here's a description of this diversity. By size and mass. Dwarf stars. Dwarf stars are smaller in size and mass compared to other stars. They can be newly formed stars or stars that have exhausted their fuel and contracted. Small and massive stars. Star clusters can contain various types of stars with diverse sizes and masses, ranging from stars smaller than the Sun to extremely massive stars known as supergiants. By temperature and color. Hot stars. Hot stars often appear blue, white, or cyan. These are typically young and bright stars. Cool stars. Cool stars have a red color and are often older stars, such as red dwarfs and red giants. By stellar evolution and age. Young and old stars. Star clusters may contain stars at different stages of their evolution. Young stars are often found in open clusters and star-forming regions, while older stars may dominate in more mature star clusters. By structure and shape. Binary star systems. Star clusters may contain binary star systems, where two stars orbit a common center. Open clusters and globular clusters. Open clusters often harbor young stars, while globular clusters tend to have older stars. By interaction and gravitational forces. Binary systems and multiple systems. Stars in clusters can interact and feel gravitational forces from each other. In some cases, stars may undergo interactions, collisions, or even mutual gravitational attractions. By dynamics and motion. Star streams. Over time, star clusters may exhibit dynamic motion, leading to the formation of star streams as stars move within the cluster. Star clusters demonstrate a rich and varied tapestry in the universe, providing valuable insights into the formation and development of stellar systems and the cosmos.